Good day everybody and welcome to another one of James's videos. Today we are going to be dealing with the trigonometry grade 11 equations. Now trigonometry equations, guys, can be split up into two different ways of asking it. The one, they can ask you for the general solution, and then the other one is asking for specific solutions. Now just a quick brief explanation on the difference between the two. A general solution, your final answer will be something that is an equation. Very similar to patterns, guys. You know how they asked you to work out your general rule for the pattern? We're kind of working out the general rule for this trigonometry equation. Okay. Specific solutions, the difference between the two and where we can notice the difference, and I'm going to highlight it now, is that you notice that here I don't have a domain, but here a domain has been given. So when a domain has been given, then it means that we can use that general solution to then solve for specific solutions of the equation. The reason also why we need a general solution for trigonometry is because trigonometry functions repeat themselves. So sine and cos repeat themselves every 360 degrees, and tan repeats itself every 180. So obviously they are continuous. So it means that when we do a general solution, we're taking into consideration the continuing trigonometry function, but where we were dealing with a specific solution, they're saying, okay, I only want the answers between 0 and 360 for this specific trigonometric equation. Okay, so we're going to start off with the general solution over here, and we're dealing with 5 cos 2 theta plus 3 equals 0. So what we would go, and I'm going to zoom in here a little bit, we're going to first thing we do with equations, guys, is we need to isolate our trig function by itself on one side of the equals. So what we're going to do is we're going to bring the 3 over. So we got that 2 theta equals minus 3. We're then going to divide both sides by 5 to get the 5 away. So now we've got cos of 2 theta equals minus 3 over 5. Now, a lot of people ask me, James, do we not need to also divide it by 2 now? No, because this is the angle, cos of the angle. Now, the angle part, guys, we always leave until in our general solution step where we simplify it. Okay, so it could be an elephant in there. It could be 2 theta plus 30 degrees. Whatever's in your angle position, we leave until our general solution step, or our step when we do our columns. So what we would do now is we've now satisfied it up to the point where we can now get a reference angle, okay? And how we get a reference angle? Our reference angle is obtained by going shift cos, so cos to the minus 1 of my fraction. Notice how I haven't made it negative 3 over 5. When we do reference angle, guys, we don't take the sign into consideration, okay? So it'll always be shift cos of the positive version of the fraction, okay? And then therefore my reference angle for this is going to be, let's do it. So shift cos on your calculator of 3 over 5, and that gives you 53,13 degrees. Now, when we do take the sign into consideration is when we work out our quadrants where we're going to be doing our general solution in. So what we're going to have here, we know that cos is negative. Do you agree? So where's cos negative? Cos is negative in the sine and the tan quadrant, second or third quadrant. And that is where I'm now going to draw in my general solutions. So we're first going to start with the second quadrant. Second quadrant is known as the 180 minus theta quadrant. And then my third quadrant is the other quadrant we're going to be dealing with, and that's known as the 180 plus theta quadrant. Okay, fantastic. So let's start with the second. So the second quadrant, remember, we always take our angle and we're now going to solve for that. So that's what's going to go first in this step. So 2 theta, whatever's in your angle position will come first. And we are now going to solve for theta. So we're going to say 180 minus my reference angle, which is 53,13 plus K360. Why K360? Because sine repeats itself. Cos repeats itself every 360 degrees, and then k is an element of integers. Okay, there's a reason why we're doing that, and we're going to get to that a little bit more when we do our specific solutions. Okay, now after that we're going to go here, same thing. It's now, instead of 180 minus, because it's the third quadrant, 180 plus 53,13 plus K360. K is an element of integers. A lot of people use N as well, N-E-Z, K-E-Z. At the end of the day, guys, it means and represents the same thing. Okay, now after that, we can simplify. So what we're going to do first is we're going to go 2 theta is equal to 180 minus my reference angle, which gives me 126,87. Guys, if they don't specify your decimal placing, always assume 2. Okay. And then we're going to divide everything by 2. So now we've got theta is equal to 63,43. A lot of people forget this, and they forget to actually also divide the K360 by 2. Okay, so if you're dividing everything by 2, everything in that equation needs to be divided by 2. And that is my general solution, guys, for the second quadrant. Okay, now we're going to carry on with the third quadrant, do the exact same thing. So we're going to go 180 plus 53.13, and that is going to give me 2 theta equals 233,13 plus K360. K is an element of integers. And then we're going to divide everything by 2. So divide that by 2, we're going to get 116,57 degrees plus K 180. K is an element of integers. Okay, everyone understand? And that would be my, let me just do this quickly, make it a bit more longer. There we go. Okay, so that would be my general solution for the third quadrant. And those are my 2 answers, guys. When they ask you for the general solution, you only need to give me the equations or the general solutions of where cos of 2 theta is equal to minus 3 over 5. Okay, so let's just look at it as a whole here quickly. General solution, we would have stopped there. Now, specific solution is actually exactly the same as general solution, just with an extra step added. Okay, so what we're going to do, I'm just going to copy paste here quickly because it's going to be the same. And we're going to bring that over, and that is exactly what we're going to do for the specific solution step. But there's going to be one extra step added in here. Now, because we know the domain is the important thing. They're saying to us, we want to know not the general solution, but the specific solutions of theta, and your thetas must fall between 0 and 360. So now this is where that k comes into play. Now, k is an element of integers. What are integers? Integers are whole numbers on the positive and the negative side of the number line spectrum. So we would start off, now if we know it's 0 to 360, we would start off by subbing in values. So I'm going to say, if k equals 0, therefore theta would equal 63,43 degrees. Now, does 63,43 fall within my domain of 0 to 360? Yes, it does. Therefore, it is a solution. We would then go one further and say, if k equals 1, therefore theta is going to equal 63.43 plus 1 times 180, which is 180. And that gives me 243.43. Now, does 243.43 degrees lie between my 0 to 360 domain given? Yes, it does. Therefore, it's a solution. Now, let's have a look if I make 2. Theta is going to equal 360 now, plus the 63.43, 423.43. Do you agree with me that that is no longer falling in my domain, which means I do not include it as one of my answers? Okay, so just bear that in mind. We're subbing in values. Let's try -1 as well. Remember, I told you it's the positive and negative side of your number line spectrum. So if I now add -1 there, theta is going to equal, so it'll be 63.43 minus 180, which gives me minus 116.57. Does that fall between 0 and 360, everybody? No, it does not. Therefore, it will not be a solution, so we can erase it. Okay, so those are my solutions for the second quadrant. Let's now have a look at my solutions for the third quadrant. So now if we make k equal to 0, therefore theta is going to equal 116.57 degrees. Does that fall within my domain of 0 to 360? Yes, it does. Therefore, it's a solution. Let's try 1. Theta, you can do a lot of mental math here, guys. You don't have to put it into your calculator. You can see whether it's going to fall out or in. So if I make that 1, so 116.57 plus my 180, and that's going to give me 296,57, and that is definitely going to fall in my domain of 0 to 360. If I make it 2, we can clearly see that it's going to be way bigger than 360, and if I make it -1, I can clearly see it's going to be a negative number, which isn't part of my domains. So that would be my 2 solutions for quadrant 3. So how would we represent this as an answer? We would put it in ascending order, and we've got 116,57, and we've got 243,43, and we've got 296,57. Okay, I'm going to show you something quite interesting now with regards to how this actually looks and what we're actually working out, because a lot of people don't know, okay, it's just equations, it's just a bunch of algebra, or it's just a bunch of arithmetic. But this can always be related to graphing. And guys, I need you to understand that they are going to start to mix this section with trig graphs, and it's not uncommon to see them all in the same question. So what I'm going to do, we know we're dealing with the cos 2 theta graph, okay? And we're dealing with the domain of 0 is to 360. So let's make our 360 here. This is 0. Let's make it a 1 here and a -1 here. So this is also, you guys need to know your graphs quite well, and you can kind of hit 2 birds with 1 stone in a way by learning your graphs, because they're only going to benefit you because you need to know them anyway for the trig graph section of your course. So what we're going to do, I'm going to draw the cos graph. Now the cos graph is y is equal to cos of 2 theta. What's happened? There's been a period change, which means that there are double graphs. So if I had to draw this graph, it's going to be 2 graphs between 0 and 360. So it means that my increments are being halved. So my graph is starting at 1, going through 45, turning at 90, up through 135, turning at 180, turning there, and going like that. Okay, so that is the cos 2 theta graph. Now, what did we just solve for? We just solved for where is cos of 2 theta equal to -3/5. Now, -3/5, guys, let's have a look. -3/5 is like -0,6. So -0,6 is like somewhere here. Okay, so if I had to draw a dotted line going straight across on the -0,6 line, how many times does that line cut the graph? 1, 2, 3, 4. How many answers did we get in our trig equation? 1, 2, 3, 4. So let's see, what are we actually solving for? We're solving for where on the x-axis of this graph does your cos theta or cos of 2 theta graph have a y value of -0.6. So let's see if it works out. I'm going to put dotted lines to these. The first one is going to be 63,43. The second one is going to be the 116,57. Are these more or less correct in terms of where it is? That's 90, so this is less than 90. This is in between, just a little bit more than 90, so that's making sense. This one is going to be the 243,43, and this is the 296,57. So every single trig equation can be graphed, and what we are solving for, guys, is we are solving for where on the trig graph does it have the y value of whatever this point is. So in this case, where does the cos 2 theta graph have a y value of -3/5? And you are working those out. 1, 2, 3, 4, those are your thetas. Okay, so I hope you enjoyed that. If you enjoyed that video, that is very, very basic. We're going to do a few types. So we're going to do type 1, type 2 from here onwards, but that is a general idea of how trig equations work, general solution as well as specific solution. If you like the video, please click the subscribe button at the bottom and like it. And all of these notes are available in the James book. And if you are keen for a copy, please let me know, comments in the section below, or just drop us a message and we'll get in contact with you and we can set you up with your James book. Awesome. Hope you have a good day, guys. Cheers.